Application to solution of differential equations. The Laplace transform method yields the complete solution, which includes both the complementary and particular solutions. Classical methods require evaluation of integration constants. However, the Laplace transform automatically includes initial conditions. Solving linear, time-invariant differential equations using the Laplace transform involves two main steps. Step 1. Take the Laplace transform of each term in the differential equation, converting it into an algebraic equation. Then rearrange to obtain the Laplace transform of the dependent variable, x of s. Step 2. The time domain solution is obtained by finding the inverse Laplace transform of the dependent variable's Laplace transform. Let's look at an example. The second derivative of x plus 3 times the first derivative of x plus 2x equals 0. We are given initial conditions x of 0 equals a and x prime of 0 equals b, where a and b are constants. First, the Laplace transform of x of t is x of s. The Laplace transform of the first derivative is s times x of s minus x of 0. The Laplace transform of the second derivative is s squared times x of s minus s times x of 0 minus x prime of 0. Now we take the Laplace transform of each term in our original differential equation. Substituting the transforms we derived gives us our algebraic equation in the s domain. Next, we recall our initial conditions. We substitute these initial conditions into our algebraic equation. Expanding the terms, we get this expression. We then group the terms containing x of s and factor it out. We isolate the x of s terms on one side and divide to express x of s as a rational function. Now we factor the denominator s squared plus 3s plus 2. We can split the middle term. Then factor by grouping to obtain s plus 1 times s plus 2. Substituting the factored denominator back into our expression for x of s, we set up partial fraction decomposition using unknown constants a and b. Clearing the denominators gives us a combined linear equation. To solve for a, we let s equal -1, which zeroes out the b term. To solve for b, we let s equal -2, which zeroes out the term. Substituting a and b back into our decomposition gives the complete rational expansion. Finally, we take the inverse Laplace transform of each term. This yields the exact time domain solution, x of t,